Hello, welcome to the episode number 10 of Implementing Exceptions with Ruby. My name is Hernan Wilkinson, I work at 10 Pines, and this is the last episode of this set of videos where we implemented an exception model using just objects and messages. On the last episode we did our model thread save, and we got rid of some class instance variables that we had on the previous implementation. There is a to-do that we haven't done yet, that is to test the default handler not found strategy, but we are not going to cover this to-do on this set of videos. What we're going to do is we're going to concentrate on some features that we still don't have. One of them is very important, the other two are just nice features to have in exception handlers models. The first one is related to the fact that sometimes when you handle an exception, you don't want to stop the you don't want to be the only handler to handle the exception, but you want to pass it to another handler. So that's the first feature that we're going to implement now. Let's go into write the next test. It's test 7. Remember that we are not worrying about the names now of the test. What we want to do is we want to have a lambda that throws an exception, for example new exception, as we have been doing on all these episodes. We are throwing the exception and we are going to handle new exception with an exception handler. Exception, well, I'm not writing very well now and I'm typing very fast. And when that handler is evaluated, we want to pass the exception to the next handler. So what we're going to do is we're going to send a message to an exception like pass to next handler, and so we will have to have another handler. We want to have another handler that is going to catch that exception, call handling new exception, and in this case we want to handle it and return some value. Okay, to have our test written correctly, what we need to do is to write some assertions, and we want to assert that the inner exception handler was evaluated. So we will set that to true, and same thing with the outer exception handler. And we'll have to set those to false at the beginning. Okay, so now our test verifies that when an exception is thrown, the handler related to it is evaluated, and when we send the message pass to next handler to an exception, then that exception has to be handled by the next handler. And we have to assert that inner exception handler evaluated is true, and also we want to assert that outer exception handler is true also. Okay, so let's see what happens if we run the test. We get an error because pass to next handler is not implemented, and that's true. So let's go to new exception. Let's see, new exception, here it is. We have to define the pass to next handler. Well, what's going on? Next handler. And what is the easiest implementation that will make this test pass? Let's see. Let's run the test and see what happens. Now we're getting a failure because other exception handler is not being evaluated, and that's because we didn't do anything special in the pass to next handler method, and we need to do it. Come on, close. I think we should move these classes to different files, but we're not going to do that now. Pass to next handler. Let's see, what does the handle method do when a handler handles an exception? So what is happening is that the exception has to be handled. It is handled here, but now we want, after handling the exception, we want to pass the exception to the previous handler. So we have to do something very weird here. Let's save the result of the handler and check if we got a special object. Let's say if result equals pass, for example, then we have to send the message handle to the previous handler, and if not, we have to return the result using the continuation. But we have a problem here. Else, okay, let's do something. Else we have this return continuation call here. Let's remove it from here and let's move it to here. We cannot use this result anymore. Okay, and let's make this look a little bit nicer. Okay, so now we have this, and the else is from this, and okay, cool. So now that we have the result, if the result was passed, then we tell the previous handler to handle the exception. If not, we tell the return continuation to call. We call the return continuation with result. Okay, let's see if everything works. We still have test 7 fail. I don't know why. Let's put a breakpoint here. Okay, okay, I know why. That's because, well, let's see it. We haven't implemented result is nil, because we haven't implemented the pass to next handler method with the right return. We have to return pass. Let's run the test, and yes, they run. So okay, we have our first feature now implemented, our first new feature, that is to pass the exception the exception to the next handler. Now we're going to implement another interesting feature that some languages have, and is the ability to retry the block that throw the exception. So we have to have something like this. We want to have a block where an exception is thrown, and we want to handle that exception. Call handling new exception, and inside that block, that handler, we want to retry the exception. So an exception, we want to send a message to it saying retry block, and this should retry the block that throw the exception. Of course, we have to put a stop to this test, because if not, it's going to loop forever. So let's have a variable here that should throw set to true, and we will throw the exception if should throw, and also we will set should throw to false when we get to the handler. So that way we will stop that infinite loop that we had before. And now what are we going to test? Well, we have to test that we evaluated the block at least twice. So we will get a counter here. We will have a counter. We will initialize that to 0, and every time we get inside the lambda, we will increment that counter by 1. So we want to assert that 2 is equal to counter. Okay, cool. I think the test is correct. Let's run it. Okay, we get an error because retry block is not defined on new exception, and let's do it. Let's go to new exception and let's define retry block. And what should we do here? Okay, let's see again the handle method. We are testing if the result is pass, and if it is, we are sending the message handle to the previous handler, and we can do the same and see if the result is something like a token that says that we have to retry the block. And if we have to retry the block, then we have to evaluate this again. So let's start saying that if result equals retry, let's say that's our token, let's return result, that is retry, and if not, let's evaluate the continuation. And now from here let's do a begin and while the result of the evaluation of the block, while result equals retry. Let's see if everything works fine. And no, we are getting 1 instead of 2. That means that, and there is another test that is failing, and that's okay. We're getting nil instead of 2 here, and I think I know the reason why, and that is because we are not returning result. Okay, let's run the test. Now we're just failing on test number 8, and let's see why. Counter is equal to 0, retry block. Okay, let's see what's going on. I don't remember if on the retry method I'm returning retry. Oh no, same problem as before. Let's return retry, run the test, and cool, everything works fine. Of course, there is some issues that we can start to see now here in the implementation of the method handle. We had a lot of if, nested ifs, and you know, an if is an indication, it is a smell that we could be using polymorphism instead of the if. But we are not going to make that change right now. Let's implement the next feature. The next feature is to be able to resume the exception from the point that it was thrown. So what we want to do is to have something like this. Let's say lambda new exception throw, call handling new exception, and in the handler we are going to tell the exception to resume execution with an object, and in this case we want that object to be, for example, 1. So we want to be sure that after the throw we get a 1, so we're gonna add another object to it, let's say 2, so the result of the evaluation of sending the message call handling to that block has to be equal to 3. So we're expecting to get 3 in result. Okay, let's see what happens. It's not running because we haven't defined the method resume with. And now let's see if we can do the same as before. with the other features. Sorry, new exception. That is going to be easier to find. Okay, so now new exception, we have to define the method resume with an object, and it would be great if we could just return something like resume and do the same implementation as before in handle, and have here an if, verifying that if the result is resume, then we just return that object that we got as a parameter in the resume. But the problem is that it's not enough to return resume. We should have to return resume and the object that we want to resume with. So we could return an array, or we could return a hash where the resume is a key and an object is the value, but that is a hack, and now the code is telling us that we need to have an object, and we need to have an object to verify the concept that we want to resume, and we need to have objects to verify the concept that we want to retry and to pass also. And then if we do that, we will get rid of these nasty ifs. So if we return some objects that are polymorphic between them, and we let those objects to decide what to do, we will be able to remove these ifs, and we will be able to do the resume with that special object that we want to resume with. So let's do that step step by step, and let's see if we can do it. So what we want to do is we want to let result define what to do, decide what to do. So let's do result value as exception handler result. So now we have to make all these objects polymorphic to polymorphic to this message. So let's say that the first thing that we have to do is to define that message in object, because we can get any kind of object as a result of the evaluation of the handler. So let's define that message value as exception handler result, and an object, if received that message, has to tell the handler to return itself. So we will have to receive here an exception handler and tell an exception handler to return itself. Okay, so now here we have to pass the exception handler, and now we have to define the message return, the method return, with an object in the handler. And what this method should do? Well, it has to evaluate the return continuation with the result, that is an object. So let's do that. Let's return the let's evaluate the continuation with the return continuation with an object as a parameter. And okay, cool. Let's see if everything is working fine. Well, everything is working but the 3 tests that we just wrote, and that's fine because we haven't implemented that yet. So now well, we had implemented but not with the new model. Now the pass is going to return an object that is going to answer the value as exception handler result, and that is going to be an object instance of the class pass to next handler. And let's call it pass to next handler action, for example. And let's define that class pass to next handler action. then when it gets the message value as exception handler result with an exception handler, it will tell the exception handler to pass to next handler. And look how we are doing it. We are not breaking the encapsulation of the exception handler, but we are delegating that responsibility to it. So now we have to define the same way as we define the return method, define pass to next handler, and we have to pass to the next handler the exception, an exception. Okay, and what we did before was to tell the previous handler to handle an exception. Okay, so now let's see a little bit more how it is implemented. Pass to next handler new with self, so we have to do the initialize that receives an exception as a parameter, and we'll keep that exception in an instance variable. Okay, so when we send the message pass to next handler to the exception handler, we will pass exception as a parameter. Let's see if everything works fine, and yes, pass the test number 7 is working. Let's make the test 8 work. That's the retry. So the retry, we are going to do the same thing. We're going to create a retry block action, and then that class retry block action, we're going to define the message, the method value as exception handler result that receives an exception handler, and here we are going to return the right now we're going to return retry and see if everything works fine. And yes, it is working, but this implementation has an issue. The issue is that well, first of all, it's not delegating that responsibility to an exception handler, so let's do that. An exception handler retry block, and now let's implement that method in the exception handler def retry block, and now here let's return retry. Let's see if everything is working fine, and yes, it is working. But the issue here is that if we always have to use this symbol retry to tell the exception handler to retry the block, we are making impossible for the programmers to use this symbol as a return object from any exception handler. So what we are going to do is that instead of having that symbol, we're going to create a token here, a retry token, that is going to be just an object, and we're going to create the exception handler with the retry token, and we're going to retry if the result is equal to that retry token. And now let's change the exception handler because it's getting a retry token as a parameter when we create new instances. Let's keep that in an instance variable, retry token, and now the retry block is going to return the retry token. So now there is no problem, we can return anything we want from the exception handlers. It is working, that is great. And now we have to make our resume work. That was all the problem, when we started to have to have all these problems. So the resume, we're going to do exactly the same thing. Resume action, that we're going to create it with an object, that is the object that we want to resume with, class resume action. We're gonna define the initialize that receive the object to resume with, and we're gonna save that in a variable, instance variable, object to resume with equal object to resume with. And now we're going to define the value as exception handler that receives an exception handler. Oops, sorry. And this is going to tell the exception handler to resume with object to resume with. And now we have to implement that in the exception handler. So let's do it. And the same, very similar way as we did before with the other options, the other features, object to resume with. And what we want to do here is to just return object to resume with. Let's run the test, and yes, everything is working as expected. There is some code that is repeated here in the return. We are calling the return continuation with an object, and here too. So let's say here return, well, let's do this self return with that, and now everything is working fine. And okay, I think that's enough for this last episode. We implemented 3 new interesting features, again something that is not common in other programming languages, and you know, we could do this because we have an open implementation. So the conclusions are that from the design point of view, we implemented not standard new features, and we use polymorphism to replace ifs again. Remember that when you have an if, that's an smell that you are missing polymorphism, so try to replace that if with polymorphism. Of course that there is a limit. It is not always possible to replace the if with polymorphism, but usually you can. From the TDD point of view, TDD help us through all this process, you know, where we implemented the model in this incremental iterative way, and that's one of the greatest features of TDD, that you don't have to design everything up front. You can do it incrementally, and if you make a mistake it will tell you, and if you want to change some design it will give you the courage to do it. As general conclusions, we have an open exception model implementation, and that is great, and it's only implemented only with objects and messages. We implemented that using TDD. We have everything tested. I know that there are some things that we didn't test, and I know that there are some errors in the implementations, but I'm not going to cover those things now. I think it's good enough for this set of videos what we did. And remember, nothing is hidden. The good thing about open implementations is that you can debug it, you can modify it if you need so, and you know, it's all for you. Remember that we could not have done this without closures. That's very important to have in programming languages, those type of objects. Now something that we say in Argentina is la hora del chivo. That means the time for an advertisement. And what I want to say that at Tempines we have some classes about object-oriented design, TDD, agile methodologies, that you can see the agenda of those classes this URL. We give those classes in Spanish and in English, so feel free to contact us. We also do development in different type of languages like Ruby, of course, Java, .NET, Python, Smalltalk, etc. So if you need to, you know, implement something, just feel free to contact us. And finally, donations are welcome. That's the donations are what we're going to use to keep doing these videos. So we have a lot of ideas for other videos, but we need to have some money to do it. So if you can give us some donations, we will appreciate that, and you can do it in our site at this URL. And finally, the bibliography that you can use to help to make grow your knowledge about the topic that we covered. Remember Lambda, the ultimate something, from Sussman and Guy Steele. Those are great papers that talk about how to implement a programming language just with closures and no special reserved words. A great book about patterns is Ken Beck's book about Smalltalk best practice patterns. There is a book also for Java, but the Smalltalk one I think is better. And a great paper that opened my mind about exceptions is the one that Christophe Doni wrote, and it's about a fully object-oriented exception handling system, the rational and the Smalltalk implementation. That's a great paper that you can read to understand everything about exceptions, and of course the book where he is author to, that is Advances in Exception Handling Techniques. That is a book that Doni with other people wrote after an ECOP, a workshop in an ECOP that took when they had a workshop about exceptions. Okay, that's all. Thank you very much. Muchas gracias, and I hope you enjoyed the this series of videos. I'm sorry if my English was not the best. I tried to do my best, and I hope to see you in another set of videos that we are going to do.